So if most elements prefer to form a chemical bond, they either want to gain or lose electrons, who's to say they can't satisfy that need by simply bonding to themselves? This is where your friend hbronclif comes in handy. Let's find out who he is and why you want to get to know him. Screencast 7.11. Well, maybe you've guessed those are the 1, 2, 3, 4, 5, 6, 7 diatomic elements that are common to the periodic table. There are more complex examples, S8 and things like that, and some of them form multiple diatomics, sulfur, S8, could be S2, things like that. But here's the most common diatomics. Read them. Hydrogen, bromine, oxygen, nitrogen, chlorine, iodine, and fluorine. It can also be taught by saying it's genene. Anything that ends with GEN or INE is a diatomic. Okay, let's combine them to form octets. Note that multiple bonds are possible. This won't be an octet because hydrogen only needs 2 valence electrons to complete its outer shell, since it's the first shell and it only has 2 electrons. There it is. That's what hydrogen looks like. Bromine, single bond should do it. Nice. Oxygen, be careful. If you combine this here and here, you're still going to have this lone camper right there. Remember how many bonds oxygen forms. And I hope you can realize that they'll look like that, a double bond. That makes this one a little bit easier to figure out, right? Nitrogen. And if you want to, you can convince yourself that there's 8 electrons, right? 2, 4, 6, and 2 shared makes 8. 2, 4, 6, and 2 shared makes 8. 2, 4, and 4 shared makes 8. You can do it like that. These are the diatomic elements. This is Screencast 7.11.